Hello everyone, welcome back. In this video, we're gonna learn how does linear search algorithm is working, and we're gonna write its code as well. In this algorithm, we need a list of items like as this one. I have created these just for an example, and in the real world, the list of the items can be either sorted or not, it doesn't matter. And our purpose is to find the search key position, which is 8 here in the list. So to do that, guys, we have to check each items one by one, starting from the beginning of the list. And if any of them is matches with the search key, then we have to return its position. So let's understand it. First of all, we will start from the beginning of the list, which is the 1, and we will check it with the 8. If they are matches, we have to return 0 as position, but because of that they are not equal to each other, we have to go to the next item, which is 5. We will compare 5 and 8 again, and because of that they are not matches, we have to go to next item, which is 8 here. So 8 equal 8, actually yes, they are equals to each other, that means they are matches. So we have to return 8's position, which is 2. So let's overwrite its code. I'm gonna create a for loop here, and I'm gonna start from the beginning of the list. So I'm gonna write int I0, I less than 5, because I know that this list has a 5 items here, and I plus plus. And I here represents the position. So I'm gonna check if any item in this position is matches with the search key. So to do that, let me write an if statement here. If numbers position I value is equal to search key, then I'm gonna show the position. I'm gonna say the item is found in this position. So I'm just gonna write cout the position is I, because I represents the position, and I'm gonna stop the loop here because I don't want to continue anymore. So when I'm going to run it, guys, as you can see we have an error here because we forgot to put a semicolon here, and let me run it. It says the position is 2 because our search key is 8, so that means we are looking for 8, and in this list the 8 is located in the position 2. So if I change this search key to, for example, 2, it should give me 3 as a result because 2 is located in the position 3. So let me change it to 2. I'm gonna stop this one, I'm gonna run it again, and as you can see it says the position is 3. So as you can see, this algorithm is very simple. In the next video, guys, we will learn how to write the binary search algorithm, which is more advanced than this one. So see you in the next video.